In this section here, we're told to graph each system of inequalities and shade only the solution of overlapping region. Okay, so that means we're going to kind of have to apply this greater than or less than or equal to or whatever, and sort of have some sort of notation, and then shade it when we're done, when we know where it all is going to go. Now, remember, y equals mx plus b. I shouldn't have to do this, but I'm going to. That's your slope, which is your rise over your run. And this is your y-intercept, okay? So again, those are things that you should have brought to the table already, but it's a quick review. 5 is your y-intercept. You're going to count up 1, 2, 3, 4, 5 and put a dot right there for that first equation. We're going to do 2 separate equations here, okay? Now, from there, we're going to look at the slope. And the slope, if we remember it's rise over run, we need to think of this in terms of 2 different things happening. We're going to drop, the rise is actually negative. We're going to drop by 3, and then we're going to run over 1. So from here, we're going to go down 1, 2, 3, and we're going to go over 1. That trend will continue until we get all the way down to here, and we run out of real estate. Before we just willy-nilly draw a line through these here, we got to look back at that arrow. Not necessarily the direction of the arrow, but if there's a line underneath. Because there's a line, we connect the dots. Whoops. In theory, with a straight line. Okay? Because of the line there, we draw a straight line. Okay? The second, and once we're done with that, now we need to look at y is less than or equal to. Now remember, y is this axis right here. It's the one that goes up and down. Y is less than means down. I'm going to show you 2 different things that people do. People will look at that arrow and think it goes to the left. Okay, now it looks like it's going to the left. If I put an arrow, it's in the same spot. But that's only going to be true about half the time, and I'm going to try and show you other instances where that's the case. So we're going to jump to the second equation. We have a y-intercept, y-intercept of -5 this time. Okay, the sign matters. That was a positive, we went up. This is a negative, we go down. 1, 2, 3, 4, 5. From there, we now have a positive 3 over 1. So we're going to go up 3 and over 1. We're going to go up 3 and over 1. And it doesn't cross at a nice place. Fortunately, we don't have to find out the point of intersection because that's not going to be pretty. And again, before I go and do anything, I look back and I'm reminded, oh yeah, it's only a less than. So it's a dotted line because we don't want to include the line. No solid line underneath. Do not draw a solid line here. Instead, we do our dotted line. And this says y is less than again. Now here's the point I was trying to make on the last equation. If I shade this thing to the left, I'd be shading over here. But if I understand that y is less than means we're shading down, then I'm actually shading what looks like to the right of it, the opposite direction that that arrow shows. Okay, so I really want to shade below the dotted line and below the solid line. And the only place where it's below both of them is where these 2 arrows agree. Okay, so this is our shaded region down here. Okay, if we decided we'd just go left because they're pointing to the left, we'd have the wrong zone, which is not a, it doesn't make the entire problem blow up in your face, but it's definitely not right. Okay, so that's what you do. The next question or next part of this is 3, -5 a solution, but we need to count over 1, 2, 3, and down 1, 2, 3, 4, 5. It looks like that point, because it's in the shaded region, is in fact part of the solution. There's an infinite number of points here. We just need to find out if that one is part of them.